Hey, geometry students. Good to see everyone. It's been a while since we been together, which is a real bummer. And many of you have been doing some of the work that I assigned on Canvas, so great job. I wanted to give a brief update. I figured out how to do videos and get those uploaded. I might be utilizing this a little bit more next week. We'll see how that goes. But I just want to give you a brief rundown of kind of where I would hope you were at with some of this new stuff. Many of you have emailed me already with some questions, and so I just wanted to clear up a few things and just again let you know what I would kind of hope that you would be at right now in terms of understanding. So I just have a couple of examples that I want to go through with you. I'm kind of just making this up as I go. I didn't really put a lot of preparation into this, but I think it'll work fine. I just have some whiteboards here that I got from my kids, and we'll make it work. So you've been studying trigonometry, and this is a real big thing that basically you can take any right triangle where you have some information given, and you can use trigonometry to solve for missing sides or missing angles. And you've learned three trigonometric functions: sine, cosine, and tangent. Each of those has a defined ratio that you can use. And so I'm just going to demonstrate kind of putting those into practice. So I think this is what you would have done on Wednesday, and then this one was one that you did today, Thursday, that should look somewhat familiar. Okay, so here's the process. In solving for x on this, I first focus on this angle that I'm given. It says it's a 36-degree angle. Always pick out the angle. You're never going to pick the right angle. It's going to be one of the two acute angles in your triangle. So you focus on that angle, and then we say, okay, what are the sides in respect to that angle? Well, this side here is across from the right angle, so that's the hypotenuse. This side here is next to the angle. This one is your adjacent. You have to be really good at identifying those sides. That's one of the first things that you need to know how to do in order to do trigonometry. Once you've done that, we don't need to worry about the opposite because we're not looking for that side, nor are we given it. So we come here and we say, okay, which trig function uses adjacent and hypotenuse? And this is a part that you have to memorize to know that you guys maybe learned this mnemonic device, SOHCAHTOA. That just helps you know which trig function to choose. So adjacent and hypotenuse, that's the A and the H for cosine. So we know this is the one we want. We know we're going to use the cosine. So we write cosine, we put our angle next, equals, and then we write the ratio that cosine is, which is, in this case, 7 over x. Okay, so that's kind of the basics to get an equation to start with. You have to start with that. Okay, now this cosine of 36 is just a specific value. It's a decimal that your calculator knows, and it has its basis in similar triangles. Okay, and we'll maybe talk more about that when we're together again. But the cosine of 36, we need to type in our calculator to make sure we can get a value for the cosine of 36. Now, make sure that you can all get this value. If you type cosine 36, you all should get 0.81. 0.81. Okay, that is the value of cosine of 36. If you are not getting that, that means you need to change the mode setting. Okay, so on this calculator, it's just a matter of going here to mode and then scrolling down to where it says radians or degrees. You need to be in degrees. Radians are another way to measure angles that you'll study in Algebra 2 and beyond, but for right now it's just degrees. So anyways, we got that. I would recommend not writing that number down yet, so just keeping it cosine 36. Let me erase that so I can save some space. All right. Now we're gonna have to solve this. So when you solve this equation, because x is in the denominator, you first have to multiply both sides by x. So x times cosine of 36 equals 7. And then to get x by itself here, we have to divide by that value cosine 36. Remember, that's just a number. That's just that decimal value that we found earlier. They cancel out there, leaving x equals, and then when you type this in, 7 divided by the cosine of 36, you get approximately 8.65. Okay. That is the length of our side. Okay, so we just use trigonometry to calculate the length of a missing side. So that was kind of what you learned about Wednesday. There's a quick example. You came up, some of the problems had square roots in them. Don't worry about that for now. I know that was kind of confusing on IXL. If you can do this, you are in great shape at this point. Down here, we're going to go through the same process, except we're going to look for an angle instead of a side. So here we go, same process. Focus on this angle. Name the sides. This is the opposite side. This is the adjacent side. Which trig function uses opposite and adjacent? Well, that would be the tangent function. So we write tangent. We put our angle next. The angle always comes after the trig function, then our equal sign, and then the ratio. Well, tangent is defined as the opposite over the adjacent, just like that. Now, how do we do this when we have to find x here? Because it's kind of part of this tangent. You can't just divide by tangent. It doesn't work that way. We have to fundamentally get rid of that tangent, which is what we call taking the inverse of tangent. So actually in this case, to come up with x, I'm going to write it like this. It's called the inverse tangent of 8 over 12. All right? So this uses your calculator again, but instead of just typing the tangent button, you see the yellow marking above mine. Each calculator will be different, but for me, I have to hit second first, and then tangent, and it gives me what's called the inverse tangent. And then I type in my 8 over 12 ratio, and then I come up with 33.69 degrees. X equals 33.69 degrees. And that's it. So that was kind of what you focused on Thursday. There you go. So there's a quick rundown. Lastly, I wanted to answer the question about rationalizing denominators. So this is what some of you saw early in the week on IXL and got confused. So let me just run through an example that might help you. Some of you have a hard time just leaving it. I told you not to worry about it, but some of you still really want to know. So I want to provide a quick explanation. When you rationalize, you multiply. Anytime you have a square root in the denominator, uses this method. So you're going to multiply by a ratio that's equivalent to 1. So it has to have the same on the numerator and denominator. And you're going to pick out whatever your denominator is here. That's going to be the number that goes on the top and bottom. So square root of 2 over square root of 2. You multiply straight across. Square root 12 times square root 2 over, and then when you take square root of 2 times square root of 2, it just comes out as 2. So that's essentially fixes getting the square root out of the denominator. We can still simplify the numerator of this a little bit, so I'm going to show you how that works as well. When you're multiplying two square roots together, you can multiply these numbers under the square roots together to get 24. Okay. Now you can't take the 2 into the 24 and make it 12 or anything because this has a square root on it, this does not. But what you can do, there's yet another step in this particular problem. I chose to pick out a problem that has multiple steps in it so you could see lots of processes. What you can do here is you can say, okay, I'm going to simplify this square root of 24 by breaking it up into two factors, one of which is a perfect square. So perfect squares are numbers like 4, 9, 16, 25, 36, on and on and on. Perfect squares. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So do any of these numbers go evenly into 24? Well, yes, 4 does. So I can do 4 times 6 gives me 24. And then what you can write next, I'll kind of wrap around here a little bit. What happened to my eraser? There it is. wrap it around here. So then I can take and make the 4 have its own square root and the 6 have its own square root. And then we say, well, what is the square root of 4? We know what that is. It's just 2. The square root of 6 is still square root of 6. And this 2 down here is that. But then in this case, this problem happens to have a situation where those 2's would cancel, just like any normal fraction. And you would just be left with square root of 6 as your final answer. So basically taking this and rewriting it as the square root of 6 through this process of rationalizing and simplifying radicals. Don't feel like you have to be an expert on this right now, but for those of you that were curious, I wanted to show you how you could rationalize the denominator and do some simplifying of radicals, because I know you came across that this week. Okay? Feel free to send me an email with more questions. I'd like to hear from more of you. Look for some videos next week and more lessons. Hang in there, everyone. I know this is a tough time. We're trying to keep everyone healthy and safe. So make sure you're keeping your distance and doing your part to stay safe and healthy. So take care, everyone. Bye.